Okay, my friend, as I told you last time, we are doing the last chapter, and this is the last chapter, what you call it, electronic structures. Let me open it for you, please. And this is your notes. Let me just open it for me. Okay, what happened? Okay, this is downloaded. And let me go to the last portion. My friend, immediately after Eid al-Fitr holidays, or maybe one day you enjoy 2 days, and then your exams are going to start soon. 29th of May, you will start your exam. Your 101 Chemistry 101 exam is on 31st of May at 11:30. Please, my friend, this is very, very important. And just to make sure, okay, my friend, let me repeat what we did before. We talked about the waves. There are three parameters for the wave: energy, lambda, and frequency. Energy E, unit joules or kilojoules, lambda meter or nanometer. We normally use nanometer. 1 nanometer is equal to 10 to the power minus 9 meter. The third important parameter is frequency. Frequency, then we have mathematical relationship between the three. And these three equations, you have to just write it down on a piece of paper, or E is equal to h mu, mu is equal to c over lambda, and from the combination of these two, E is equal to hc over lambda. In these three equations, you have seen something new, h and c. H, Planck's constant, value 6.626, 10 to the power minus 34 joules second. My friend, one of the students asked me, it is joules per second. No, no, no. Joule second multiply, joule second together. The velocity of light we normally denote as small c, speed of light, velocity of light, 3 into 10 to the power 8 meter per second. Meter per second. These three equations are very useful to calculate lambda, frequency, and energy of any radiation which you have seen in electromagnetic spectrum. In electromagnetic spectrum, the only radiation which you can see is the visible region. Visible region start from 400 nanometer to 700 nanometer. 400 nanometer is the color what you call violet, indigo, or banafsaji in Arabic. 700 nanometer on the other hand, it is red color. So lambda means wavelength. Lambda means wavelength. So if I know lambda, I can get frequency and I can get energy. So to calculate frequency, mu is equal to C over lambda, 3 into 10 to the power 8, 710 to the power minus 9. I have done this correction before just to make sure. So you have checked these answers. If you want energy, H mu, you know H constant, you know this, and you can get energy. You can use any equation you want, you can calculate the remaining parameters. In the second example, frequency is here. The unit for frequency is second minus 1 or hertz, Hz. In this example, I have given you frequency, I want energy and lambda. You have all three equations. Whichever you like, whichever you want, you can use it. So I use A is equal to H mu. I know frequency, I know H, I can get energy. I can use this equation mu is equal to C over lambda, or lambda is equal to C over this. This is the unit in meter. If you want to calculate in nanometer, then what you should do, I told you, make a bracket, make a straight line between the bracket, the unit you want, put it up. The unit you don't want, put it down. So 1 nanometer will come up, 10 to the power minus 9 meter will come down, meter cancel, and then you can get the value and you can get the answer for lambda. Then I talked about how do we produce radiation. We produce radiation from different jumping from a high to low, from a higher level to a lower level, higher level to a lower level, my friend. This is Lyman series we talked about, from high to low. Low means n is equal to 1 throughout. So when you see Lyman series, it means n low equal to 1. Similarly, when you see Balmer series, n low equal to 2. When you see Paschen series, n low equal to 3. And this is the most important equation. This is the most important formula that you can use in this chapter. E is equal to RH, 1 over n low square, 1 over n high square. I am repeating, I have done it before, I am repeating right now that for the time being, for this chapter, for this course, we are talking about jumping of electrons from top, from high to low only. We are not going from low to high. No, no, no. Only from high to low. So if it is high to low, and if n low is 1, Lyman series, if n low is 2, Balmer series, if n low is 3, Paschen series. This is the equation. You can calculate lambda, energy or frequency for any radiation. Then I gave certain example, 5 to 2. So 5 is my n high, 2 is my n low, R is a constant for hydrogen atom. RH means constant, Rydberg's constant. Rydberg, Rydberg, Rydberg's constant, value 2.18, 10 to the power minus 18. Minus 18. I know 1 over 4, 1 over 25 because it's square. I got the energy. Once I got the energy, the remaining parameters you can calculate. Similarly, go for another jump, 6 to 1. That means 6 to 1. 6 to 1, you know n high, you know n low, and you can use the same thing, and you people have checked the answers also. Then this example, a line observed. I have given you three example. I don't want to use this. I want to use the previous equation, but I have used E is equal to RH bracket 1 over n low square minus 1 over n high square. Now in Lyman series, a line observed at this in Balmer series. Balmer series means I know the value of n low, which is 2. So 2 square will be 4. N high I have to find. This is my lambda. This is my lambda. Can I get energy? Yes. Which equation I am going to use? Very simple. E is equal to E energy, E equal to HC over lambda, HC over lambda, H Planck's constant, C is speed of light, lambda 397.01, 10 to the power minus 9 meter. Do calculation and you can calculate n high. Whenever you do this thing, please go step by step. This is my value for E is equal to HC over lambda. I brought RH here. I got the answer 0.23. This is Balmer series. So 1 over 2 square is 1 over 4. 1 over 4 means 0.25. I bring this 25 on this side. So this is going to be minus 0.02. Minus cancel, and you can bring the square root of the answer, which will be 7. Similarly, you did this, a line obtained at 97.23 in the Lyman series, so you can calculate n high. And then the last equation I did for Paschen series, and this is just to give you practice. Then I ask you to do these homework if you have time. I know you people are busy for English, for physics, for mathematics exam, but my friend, this is for you because this is Mawjood. So just to make sure. Then we talked about quantum number. Quantum number, my friend, very, very important. Quantum number to locate an electron in a given atom, to find the possibility, to find the probability, to find an electron in a given atom. And before that, I gave you the picture after the nucleus. I will come to this page later. First, let me go down. So this is my picture, my friend. This is my nucleus, first level, second level, third level, fourth level. K, L, M, N. These are level. These are also known as first quantum number. In the first level, we get a maximum number of electrons 2, second one 8, third one 18, and the number 4 is 32. This is not the end. You can also continue, but this one is more than enough for me for this course. If you want, you can go further. It's up to you. How do I know that the maximum number of electron I can calculate is 2n square? 2n square, n is the number of level. So if the number of level is 3, so 3 square is 9, multiply by 2, 18. 18 means I can have maximum number of electron in third level is 18. I can have 17, but I cannot have 19. So then this was the first quantum number known as level. The second quantum number is known as sublevel. For sublevel, we denote small l. Small l. If l is equal to 0, we call it S sublevel. If l is equal to 1, we call it P sublevel. If L is equal to 2, we call it D sublevel. If L is equal to 3, we call it F sublevel. The maximum number of electron I can have is S is 2. Here 8, so I have S and P. If L is equal to 0, S. If L is equal to 1, P. Now, my friend, for S, there is only one box. I have done this correction. Those people who have joined me today, S, only one box. P, 3 boxes. D, 5 boxes. Each box maximum 2 electrons. Each box maximum 2 electron. I can have one, no problem, but I cannot have 3. So S sub-level, one box only. So cancel this, make it one box here. P, one box only. D, 5 boxes only. F, 7 boxes only. Then I go back to my previous page. So quantum number, the first one we denote as N. N can be 1, N can be 2, N can be 3, N can be 4, N can be 5. Depends. If N is equal to 1 means first level, N is equal to 2 means second level, N is equal to 3 means third level, and N is equal to 4 means fourth level, and so on and so forth. Each level has a maximum capacity. N is equal to 1 means maximum 2 electrons. N is equal to 2 means maximum 8 electrons. N is equal to 3 means maximum 18 electrons. And N is equal to 4 means maximum 32 electrons. The second quantum number, I just mentioned it, L is equal to 0, 1, 2, 3, S sublevel, P sublevel, D sublevel, F sublevel. If S sublevel means ML, the third quantum number depends on L. So if L is 0 means S. S means ML equal to 0. So ML equal to 0 means one value. One value means one box. L is equal to 1 means P sublevel. P sublevel means 3 boxes. What are their addresses? -1, 0, +1. Similarly, L equal to 2. 2 means D sublevel. D sublevel means 5 boxes. L is equal to 2 means 5 boxes. What are those 5 boxes? -2, -1, 0, +1, +2. Similarly, F. A maximum electron in each box is 2. I can have 1, but I cannot have 3. Then I showed you this picture before. Then how to use it. Then before that, how to use it, I gave certain examples. 3s1, I just want to repeat because I got request, my friends, from some students that please, so I can, because there is no formula. The reason, so it will be easier for you to understand. 3s1, the very first number gives me n. Always remember we have a set N, L, ML, and MS. MS is spin quantum number. In this chapter, we will only work for 1 electron. Sometime in Imtihan, it is given only 3s. You should understand that I am talking about 1 electron. 1 electron. So just 3s1, 1 electron, 1 electron. So this is a set N, L, M, L, M, S. They will give you this, write down the set, or they will give you set, write down this. So this is 3s1. So 3 is the first number, means n is equal to 3. I put 3. I have s here. S means L should be equal to 0. If L is equal to 0, S. If L is equal to 1, P. If L is equal to 2, D. And if L is equal to 3, F. So from this notation S, I found 0, and because L is 0, ML is also 0 because only one box. The last column is plus half or minus half because I have only one electron. So the possibility to choose electron upward direction or downward direction. Upward direction plus half, downward direction minus half. So you can write, you don't like plus half, you can put minus half. Then I gave you another example for so many like this, and then you saw it. My friend, 4p1. So the number 4 is here. L is equal to 1 means 1. And I have minus half or plus half. There was a question, there was a concern that for P I have 3 boxes. 3 boxes means minus 1, 0, plus 1. So which value I should write? My friend, my beautiful people, you can write down any number you like. If you like minus 1, faddal. You like 0, faddal. You like plus 1, no problem. Similarly, 3D1. So I have 3 because n is equal to 3. D, so L is equal to 2. And I have 5 values, 5 boxes. Minus 2, minus 1. 0, plus 1, plus 2. I choose or he choose minus 2. You don't like minus 2, write down minus 1 anywhere. This is what you have. Then I gave you some more examples, my friend. This is the more example I have, and you have to be careful when you write down the answer. This is 2 means 2 number will come first. L is equal to 1 means P. Okay. This is 3, this is 2, so 3D. Okay, because this could be plus, this is plus 2. But here 40 means 4s. 40 means 4s. But the value for third one, magnetic quantum number or ML, if L is 0, ML should be 0 also. I have written minus half. Minus half means not possible. Similarly, I wrote down 220 this, that means it should be 2D. I cannot have 2D because in the first level I have S, in the second level I have S and P. So D start from third level. So this should be 3 as I have shown you here. I cannot have D in the second level. I cannot have D in the second level. So again, I said not possible. Then my friend, we talked about the electron configuration. Thank you. You have sent me beautiful pictures from 2-3 people, mashallah. Follow the diagram, print it out. Please print it and keep it in your on the table so you can be easily, you can do it. How to distribute the electron, my friend? I have done it in 2 ways. One is called normal configuration or ground state configuration. Normal configuration or ground state configuration, or can I write down mukhtasar or in the simple form? Yes, you can. I showed you the periodic table, and then you know how to write it down because Ne3S1. Ne means inert gases, argon, inert gases. So Ne means neon. Number of electrons are 10. So this is, instead of writing the whole thing, I will write down Ne and whatever is the remaining. We did this so many examples, and this is called ground state electron configuration. This is repetition, my friend. This is all ground state configuration, repetition, nothing new, repetition, my friend. Then electron configuration, Fe. Fe again, 4s2 comes first. Follow the diagram which you have. Follow the diagram, my friend, you have, and just you can write it down easily, my friend. Normal electron configuration. I don't know how to write down the mukhtasar, very simple. Fe Look at Fe in your periodic table, take a right turn, go Sirate Mustaqim, see you will see krypton. Once you see the last element in your inert gases, last group, Kr, just go one up, and one up was Ar. Ar means number of electrons, 18. 18 means up to here is 18, and whatever is remaining you can write it down here. Similarly, you can write down for titanium, and my friend, you can do a lot. Then I simply emphasize for chromium and copper. I want you to be very careful when you are dealing with chromium and copper. When you are dealing with chromium and copper, as I told you, they are very special. They came from Jannah. They are very, very special. So what is so special? Generally, you write it down 4s2 and then whatever 3d is remaining. But for chromium and copper, because of their stability D5 and D10, 4s1 3d5, 4s1 3d10 for copper. This is only for chromium and copper. Chromium and copper. Chromium and copper. So be careful. Now, my friends, something new I will start here. I just wanted to give you a brief idea. I have Fe26. You have seen it in the previous page. Ar4s2 3d6. This is Fe. My friend, ayyuhal muslimun, my beautiful people, if I lose electron, if I remove electron, it becomes iron. This is atom, this is iron. 2 plus means I lost 2 electrons. 2 plus means I lost 2 electrons. 3 plus means I lost 3 electrons. Now, some people do this big mistake. What do they do? The question is Fe2 plus, write down the electron configuration for Fe2 plus. The best tariqa, the only tariqa is write down the normal configuration, write down the normal configuration as you don't have 2 plus. Write down the normal configuration, and this is my normal configuration. Now 2 plus means I lost 2 electrons. I lost 2 electrons. So in this one, which one I filled first? 4s or 3d? I filled 4s first, then 3d. So always remember, I have written it here. Always remember, remove electrons, the one you filled first. So I filled 4s first. So I will remove 2 electrons from there, and then I will write down remaining is 3d6. Some people do this big mistake. What do? They take 26 minus 2, 24, and then they start writing the electron configuration. No, no, no. Don't do that. Never ever do this. Write down your normal configuration, and from your normal configuration you can remove the number of electrons, either +1 or +2 or +3. +3 is over here. I will write down the normal configuration Ar4s2 3d6. 3 plus means I lost 3 electrons. So 2 from here and 1 from here, and this is the electron configuration. If you say 26 minus 3, 23 and start writing, no, then people will take your picture and put it where? Instagram. Copper +1, chromium plus copper +2, chromium. Again, write down the normal configuration because chromium and copper are very special. So copper special one, 4s1 3d10. This is the normal one. This is the normal configuration. Now I say +1, so I lost 1 electron and I get a 3d10. Similarly, +2, write down the normal configuration. Never subtract. Write down the normal configuration, and after normal configuration, remove electron. How many do I have to remove? Two. So one from here and one from here. So it will become Ar3d9. Always remember, whenever you have copper and chromium, you have to be very careful, because in case of chromium it is 4s1 3d5 in the final shell, copper 4s1 3d10. So I have chromium 3 plus. So don't do 24 minus 321 and start writing. No, no, no. Write down the normal configuration AR4S13D5. I have 3 plus means 1 from here, 2 from here, so the remaining is 3. Like this. Now, my friend, you can have very Hund's rule. Hund's rule, nothing important. Hund's rule. Hund's rule says nitrogen. I'll give you the example, then I will explain you the definition. What is this Qanun says? N7. How do you write down the electron configuration? 1s2, 2s2, 2p3. How many boxes I have for S1 box? How many boxes do I have for S1 box? How many boxes for P? I have 3 boxes. Now, can I write down 2 electrons here and 1 here? The answer is no. Can I write down, instead of Broha, can I write down 2 electrons here and 1 here? The answer is no. Why no? Because according to Hund's rule, it says that if orbitals are available of equal energy, these 3 boxes are of equal energies. If orbitals or boxes, same thing. If orbitals or boxes are available of equal energy, then electron want to have a parallel spin. Parallel spin, I knew the word mutawazi. Mutawazi means parallel. Correct, mutawazi?
Yes.
Okay, thank you. So I pass Arabic exam. Shukran. Similarly, oxygen 8, 1s2, 2s2, 2p4, so 2 here, 2 here. I have 4 electrons, so 1, 2, 3, and then again 4, because I don't have any other space. So I have to make it pair. I have to make it pair. Then, my friend, something extraordinary important. Something extraordinary is important. Look at this. What did I say? Chum star? Chum star?
18.
80 star.
Mm,
What do you mean by
8.
80 star? Yani mawjood amu
Yeah.
mawjood.
Mawjood.
What is the question? The question is very, very simple question. Very, very simple question. What is the question, my friend? I have given you manganese 2 plus atomic number 25. And the question is, how many unpaired electrons it has? Unpaired electron means Broha. And is this paramagnetic or diamagnetic? Paramagnetic and diamagnetic. My friend, paramagnetic means attracted by a magnet. Diamagnetic means not attracted by a magnet. What is paramagnetic means? Paramagnetic means it is unpaired electron, maybe 1 unpair, maybe 2 unpair, maybe 3 unpair. Even if it is 1 unpair, it will be paramagnetic. Paramagnetic means electron Broha, electron alone is always attracted by a magnet, because alone electron itself is a magnet. Electron alone is itself is a magnet. Electron alone is itself is a magnet. So even if you have 1 electron only, it will be paramagnetic. Paramagnetic means the electronic configurations which contains unpaired electron or electrons. But if there is zero unpaired electron, no unpaired electrons, then we call it diamagnetic. I will give you the example for manganese. Write down the normal configuration. 80 stars, so what? Very, very simple. This chapter from quantum number to the end, whenever I will finish, you will get at least 4 to 5 questions. From this chapter only, you will get 5 questions, maybe more, 5 minimum. These questions in this chapter, it doesn't take much time. So I would always focus on these, and I will try to solve my 5 or 6 questions from my final exam or from my final exam. This chapter, by the way, is not included, so you can solve easily. So the first step, the question is how many unpaired electrons and whether it is paramagnetic or diamagnetic. Whether it is paramagnetic or diamagnetic. Very simple. Write down the electron configuration for 25. AR4S2 3D5. This is my normal configuration. This is my normal configuration. This is my normal configuration. 2 plus. 2 plus means I have to remove 2 electrons. Which one I will remove from 4s or 3d? Which one I will remove from?
4s.
4s, because the one you filled first, remove first. So now my AR3D5. Next step. I know that d orbital has 5 boxes. D orbital have 5 boxes. D orbital has 5 boxes. 5 boxes according to Hund's rule. If orbitals of equal energies are available, they would like to have a parallel spin. So 5 means 1, 2, 3, 4, 5. How many unpaired electrons? 5. How many unpaired electrons? 5. Paramagnetic or diamagnetic? Paramagnetic. Why paramagnetic? Because you can see 5 unpaired electrons. My friends, suppose this is paired, this is paired, this is paired, this is paired. Only one unpair. Only one unpair. Again, it is paramagnetic. Copper plus 1. Another example. Copper plus 1. How many unpaired electrons, and it is paramagnetic or diamagnetic? Very simple. I will write down the normal configuration 4s1 3d10. Then plus 1 means I will remove this and I have AR5d10. How many unpaired electrons? 0. I don't have any unpaired electron. Whether it is going to be diamagnetic or paramagnetic. Diamagnetic or paramagnetic? Diamagnetic. Why diamagnetic? Because I don't have any unpaired electron. Another example, so many examples I'll give you. Cr3 plus. Atomic number 24, Cr3 plus. Write down the original normal configuration. Original normal configuration AR4S1 3D5. 3 plus. 3 plus means I lost 3 electrons. 1 from here, 2 from here. So it will be AR 3D3. I know that D has 5 boxes. So 1 here, 1 here, 1 here. So how many unpaired electrons? 3 unpaired electrons. Either it is para or di. So para. Another pair electrons, my friend. Vanadium 3 plus. Vanadium 3 plus. Vanadium 3 plus. Vanadium 3 plus means Ar 4s2 3d3. 3 plus. 3 plus means I lost 3 electrons. 2 from here, 1 from here. Write it down Ar 3d2. I have 2 electrons, d orbital, 5 boxes, 1 here, 1 here. So how many unpaired electrons? 2. How many unpaired electrons? 2. How many unpaired electrons? 2. Paramagnetic or diamagnetic? Of course, paramagnetic. Zinc 2 plus. Zinc 2 plus. Write down the normal configuration. Ar 4s2 3d10. Normal configuration. 2 plus means I lost 2 electrons, so I lost 2. It will be Ar 3d10. I have five boxes, 2, 2, 2, 2, 2, and this is diamagnetic, 0 unpaired, diamagnetic, 0 unpaired, diamagnetic, 0 unpaired, diamagnetic. I will give you an example which is not here just to test you, just to check with you. Ni nickel, Ni plus 4, Ni plus 4, Ni plus 4. What is the number of unpaired electrons? How many unpaired electrons? Is this Ni4 plus para or di? I am waiting for your answer in the telephone. I am waiting for your answer, my friend. How many unpaired electrons is this para or di? Okay, my friend, I got the answer from Muhammad. Ni4 plus 28 is the atomic number, so 4s2 3d8. 4 plus means I have 4s2 and then what is this? My friend, Ni plus 4. First normal configuration. What is the normal configuration? Ar4s2 3d8. Okay, so when you have 3d8, I have 4 plus, so I removed. When you remove electron, you remove 2 from S and 2 from D, so it will become 3d6. So 3d6 means How many unpaired electron? 4 unpaired electrons. 4 unpaired electrons. Do it again, please. Ni4 plus. Normal configuration AR 4s2 3d8. Did you write? Good. 4 plus. How will you remove electrons? You will remove electron 2 from 4s and 2 from 3d8. So how many electrons remaining in 3d? 6. I have 5 boxes. 5 boxes means 1, 1, 1, 1, 1. And at first box, it will be paired. So how many unpaired electrons? 4. How many unpaired electrons? 4. Para or di? Para. Do you understand this, or yes or no?
Yes.
I will give you another example. V like vanadium. V plus 5. V plus 5. I want to know how many unpaired electrons, para or di. Vanadium, V. I can show you because I have the answer here. Here. Vanadium 3 plus, no, 5 plus. So if I say 5 plus, how many electrons did I lose? 5 plus. How many electrons did I lose? 5 plus.
5 electrons.
5 electrons. 2 from here and 3 from here. So I have only AR. AR means, do I have any unpaired electrons?
No.
So 0 unpaired electrons. Para or di? Para or di?
Die.
Die, because there is no unpaired electrons. So this is what you have, my friend. This is very, very important, and I want you to, now I would like you to do Mn manganese, atomic number 25. Mn4 plus. Mn, I have this, so I can show you from here. Mn4 plus. Okay, this is my normal configuration. 4 plus. 4 plus means 2 from here and 2 from here. How many electrons remaining in D?
3.
So how many unpaired electrons?
1.
How many unpaired electrons? 3. When you have 3, how would you write 3? 1 here, 1 here, 1 here. How many unpaired electrons?
3.
3. Para or die?
Para.
Para. So this is how you solve it. This is how you solve, my friend. This is how you solve. One more example. Cobalt 3 plus. Atomic number 27. Cobalt 3 plus. I want you to do it on the paper and then take a picture and send me. Cobalt 3 plus. Cobalt 3 plus, atomic number 27. How many unpaired electrons? I am waiting for the answer. What will be the configuration? Normal configuration AR4S2 3D7. AR4S2 3D7. Now you have cobalt 3 plus. 3 plus means I will take 3 electrons, 2 electrons from S and 1 electron from 3D7. So I will have 3D6. I have 5 boxes. So 5 straight and the first one will be paired. So how many unpaired?
4.
4 unpaired. Para or die?
Para.
Para. My friend, don't even think if you have 1 unpair or 2 unpair or 3 unpair or 4 unpair or 5 unpair. I cannot have 6 unpair. Difficult. So immediately, and if it's all paired, it is diamagnetic. So my friend, I will stop here. I will stop here for isoelectronic structures, which is here. Isoelectronic structure, which is page number 94. My friends, if Eid al-Fitr announced on Wednesday, of course we will not have class. Then we will meet whenever the classes will start. But if there is no Eid al-Fitr, Yawm al-Arba'ah, if there is no Eid al-Fitr, my friend, we will have our normal class. So I request you not to miss, because maybe I will cover it up and finish it up. So I don't want, if there is, I don't want to rush. If there is Eid on Yawm al-Arba'ah, okay, it's your holiday. Thank you. If there is no Eid on Yawm al-Arba'ah, Eid is on Yawm al-Khamis, then we will have the normal class at 1:30. So please listen very carefully. And my friend, I have 32 people. I am requesting you now, 33 people. There are still some people that did not do the evaluation. I would request you to please spend 2 to 3 minutes for me and do it. Please do it now. Those people who didn't do it, your sections are from 25 to 30. Please do it now. Thank you. I am waiting. Please do it now because you have time. Take out your mobile and do it. My friend, thank you very much. So if there is a Eid on Yawm al-Arba'ah, Eid Mubarak, Kul Aam wa Antum Bikhair. And if there is no Eid, I will repeat the same Kul Aam wa Antum Bikhair on Yawm al-Arba'ah. Thank you so much. Jazakallah khair. And let me, but don't forget to do the evaluation, please, now. Let me stop recording. This is my recording. I stopped.